in the test lab.
Wind machines are actually very often referred to as frost fans. They're dealing strictly with cold temperatures to distinguish those from wind turbines that are used for generating electricity. So what we're looking at in the background is actually a wind machine. And wind machines been around for a long time. They were actually a technology was developed way back in the 1930s in the United States to deal with frost, spring frost, late spring frost. And the way they work is they have, as you can see, a huge fan at the top, and they're powered by an engine. It's a 250 horsepower engine. They use either propane, electricity, or gasoline as a fuel. And what they do is the machines turn around at a very, very rapid rate at roughly about 600 and something revs per minute, really fast ones, some 440 revs per minute. And what they do is they rotate at the same time in 360 degrees. But what they do is they pull warmer air from above and mix it with the cold air closer to the floor of the vineyard. Wind machines can only work when you have an inversion.
Okay.
And those inversions are typically present under clear, calm conditions in the late spring when you might have a frost, or even in the winter. You might have an inversion present. In the winter, of course, temperatures are much colder, but again, the temperature at the canopy level might be minus 20 degrees, which is potential for damage there, bud damage, cane damage. But above it, the temperature at 60-foot level, the temperature might be minus 10 degrees. So you have a very, very big difference. That's the inversion strength, the difference between the ground temperature and the temperature at the upper level. There are different types of wind machine. This one that we're looking at in the background is what we call an overhead machine. And the height of the tower is about 35 feet. You don't want it to go any higher than that, because if you go any higher than that, you have to remember you have to pull the air and you have to push it forward and create a movement closer to the ground.
Right.
So the higher you go, of course, the less effective. So that has been the, if you will, the optimal height based on a lot of studies. Also, we have machines that, these are fixed machines, so they're stationed, but you can have portable ones. They're huge fans that you can pull behind a tractor, and those can be placed between the rows, and they can work that way as well. The main benefit, of course, is to prevent spring freeze damage, whether it be from a late spring frost or winter, or actually extending the growing season in the fall, because if you have a major frost in the fall, temperatures drop to -2, then you have the canopy, of course, is damaged. You have to harvest. So if you can prevent that, then you can actually extend the growing season by preventing that first fall frost. They require minimum maintenance. As I said, during the growing season, they just sit there. And so the only time they're used in the late spring, and of course they may not be even used in the fall, right? It depends on the situation. And maybe 4 or 5 times, in some cases up to maybe 7, 8 times in the winter. So the maintenance is quite low, quite apart from making certain that the engine is tuned up and is oiled, and there's not much you can do to the fan, quite apart from the occasional inspection to make certain that no cracks. So maintenance is relatively low. Students who want to get into renewable energy should first of all understand the technological aspect, how these machines work, the engineering aspect. They should understand the meteorological aspect, what are the critical wind speeds and direction, how you measure those, how you do an assessment, and so on and so forth. What are some of the topographic barriers? What are some of the optimum conditions? What are some of the areas that are not conducive to the location of wind generators? So we're not just looking in one area of the science, just the engineering aspect, but you should have some background in climatology, meteorology, topography. GIS becomes very, very important, because we can use GIS software to analyze an area. We can model the airflow in that area. to see where the obstacles are, how far away a machine should be sited from buildings, from major natural topographic features, and sensitive areas such as any nearby settlements, small town villages, and so on and so forth.